All right, here is a kind of walkthrough of the polynomial study guide. So if you're feeling stuck on how to do any of these problems, you can go through this video and kind of see how I would do them. So this first one, right, we're looking at our end behavior. We can look at our chart up here, right? We just care about our degree and our leading coefficient. So this one has a degree of 3 because that's my biggest exponent. Right? So I'm going to say degree equals 3. And my leading exponent, if I just have a negative, that's a -1, right? That's my leading coefficient. So we can kind of look up here, right? We see that I have an odd degree and a negative leading coefficient. So as x goes to infinity, y is going to negative infinity. As x goes to negative infinity, y goes to positive infinity. All right, so this one, degree of 2. Leading coefficient is 3. So here it's even. So we know both sides are either going to be going up or going down. Here, since my leading coefficient is positive, both are going to infinity, right? Okay. Here, this one's a little tricky. Our degree, highest degree is actually this term right here. So my degree is 5, and my leading coefficient, 7, right? So it's an odd degree and a positive leading coefficient. So this will just match up as x goes to infinity, y goes to infinity. As x goes to negative infinity, y goes to negative infinity. All right, for this one here, when it's something like this, it's hard to tell exactly what our degree and leading coefficient are, so we can distribute. So let me FOIL this out real quick. Let me do something like here. I'm just going to do the first two. So in here, I have x squared. So it's plus 4x minus 2x is going to be plus 2x minus 8. Let me do it by 1 minus x. We can FOIL one more time, right? We get x squared times 1, which is x squared. X squared times negative x is negative x cubed. And then we can do it again. 2x times 1 is plus 2x minus 2x squared. And then minus 8 plus 8x, right? So really all we still care about is our term with the highest degree, which is this one right here. So I have a degree of 3 and a negative leading coefficient. So looking at our table, we can tell that it's going to be like this one, right? Okay. So here, I could do the same thing with the foiling, right? But that would take a long time. I could also just graph. So I could plug this in and graph and take a look, right? So I could graph this in my TI. But just, I can tell here I'm going to have an x, and an x, but this one's squared. So I'll have a degree of 4 actually, right? Because this counts twice. And I have 2 more x's. And my leading coefficient, let me just pretend it's this guy right out here, this -2. All right. So here I have an even degree and a negative leading coefficient. So both of these are going to negative infinity. All right, let's look at these, right? So here, these values, -2, 3, and 6, are my x-intercepts, right? We get that from looking up here. Now, really all we need to do is we have 4 intervals, right? Less than -2, in between -2 and 3, and in between 3 and 6, and then greater than 6. We want to determine, are we positive or negative at these intervals? So let's plug in a value. If I plug in something here, right? Let's plug in -3, since -3 is less than -2, right? So let me do this. Just plug it in for x, right? We'll make x a -3. So let's say -3 minus 3, 6 minus -3, and then -3 plus 2, right? And let's see what we get. So this one is -6. 2 negatives is a positive, so this is 9. This is -1. So if I have 2 negatives, and remember we're multiplying all these together, right? -6 times 9 times -1 is actually going to give me a positive result since I have 2 negatives. Those will cancel out, right? I can do this for the next ones, right? So now let's say for here, in between -2 and 3, I'll just plug in 0. I could plug in 1, I could plug in -1, but 0 is probably the easiest, right? So I'll do 0 minus 3, 6 minus 0, 0 plus 2, right? So we get -3, 6, and 2, right? Here I just have 1 negative, so this will end up being negative, right? Now let's do these last 2 real quick. So I'm going to plug in 4. Let's plug in 4 and see what we get. So we get 4 minus 3, 4 minus 3, 6 minus 4, 4 plus 2. get this is 1, 2, and 6. 1 times 2 times 6 is positive, right? Okay, and lastly, let's plug in a value greater than 6. Let's just plug in 7. So we get 7 minus 3, 6 minus 7, and then 7 plus 2. So let's see what we end up with, right? We have 4, negative 1, and 9, right? Here I have 1 negative, so this will be negative, right? Now I can kind of fill out the rest of my sign chart, right? Here, boom. We know we're going to look like this. Now from these sign charts, we can really tell our end behavior, right? Here we know as x is going to infinity, y is going to negative infinity. As x is going to negative infinity, y is going to positive infinity. All right, this next one we got to fill in our x-intercepts. So here I see we have positive 2, negative 1, and negative 3. So let's go negative 3, negative 1, and positive 2, right? And then we can just plug in our values, right? So here let's plug in, I don't know, negative 4. Let's plug in negative 2. And for this one, let's just plug in, I don't know, 0, right? So I'm actually, just for the sake of time, not going to plug these ones in, but I think we end up with plus, minus, plus, plus, right? If you have questions on how to do this, come see me, right? Now we can draw our sign chart. We go positive, negative, and then positive. But remember here, we still touch the x-axis here, but we bounce, right, and go right up. We don't actually cross. So we see our end behavior is going up in both directions, right? We'll talk about multiplicity later, but that's kind of what's happening here because this root has a multiplicity of 2. All right, now this one, a little bit harder because I need to factor first. So let's factor this thing. I notice that I can take out an x cubed from all of these, right? And let's see, I'm left over with x squared minus 5x plus 6. So if I want to factor this, this will end up equaling, let me drag this over here. This will equal, so the x cubed. Now in here, I see negative 2 and negative 3 multiply to 6 and add up to negative 5. Cool. So I get my 3 x-intercepts, right? So first one is actually 0, and that comes from this x cubed term, 0, 2, and 3, right, from our 3 x-intercepts. Okay, so we have our 4 intervals. So I could plug in negative 1, could plug in 1, and then here this is a tricky one since there's not a whole number between 2 and 3. So I'm just going to plug in maybe like 2.5, and I'll plug in 4 here, right? So once again, right, you can just plug these in for x, kind of like what we did in this last example, but we end up getting a negative, positive, negative, positive, right? So it ends up looking something like this, right? My numbers are kind of in the way, but that's the idea of what our polynomial will look like. All right, let's move on. So here, let's talk about how can we kind of derive the equations of some of these polynomials, right? So for this one, right, we should start by kind of writing out my x-intercepts. Here we see we have 3 x-intercepts, negative 2, 1, and 2, right? So let's start by writing out y equals, and I'm going to write my a, because that's kind of that scaling factor. We don't know what a is. We'll solve for that in 1 second. And now we can write all of my roots. So for this x-intercept, negative 2, remember we kind of want to put the opposite. So here, instead of negative 2, we'll do x plus 2, right? And that's because if I make x negative 2, then this thing will equal 0. Negative 2 plus 2 is 0. So it's going to be the opposite. So for this one, for 1, it'll be x minus 1. And then here, x minus 2, right? Now, we have this concept of multiplicity, right? Here's this chart, right? Multiplicity, right? If we go straight through the x-axis, we'll have a multiplicity of 1. That means we're basically raising these powers, or these roots to the power of 1. Now, all of these go straight through, right? So here we don't really have to worry about having here, but if we have it just kind of go to the x-axis and bounce off, right? That'll have a multiplicity of 2. The next one we'll look at will have a multiplicity of 3. Cool, but these all have a multiplicity of 1. Now we need to plug in a value to find a. Now we have this value right here, 0, 4, right? When x is 0, y is 4. So we can plug that in. Let's make y 4, let's leave a as is, and let's make x 0. 0 plus 2, 0 minus 1, 0 minus 2, and let's see what we get, right? So this is really 4 equals a times 2 times negative 1 times negative 2, right? Which is just 4. So we get 4 equals 4a. So a is just 1. We can divide by 4, and we get 1 equals a. So let's write out my final equation. It's really just going to be y equals, now since I can just write a 1 for my a, but we don't really need that one. So my final equation will be this, x minus 1, and then x minus 2. Cool. Let's try a different one. Let's look at this, right? So here we see my two x-intercepts, 2 and negative 1. But this negative 1, it kind of looks a little bit different from this one, right? This is what we call it, where it's like slithering through. So here this looks like, if we go back to my multiplicity chart, that root actually has a multiplicity of 3. So for this one, we can write y equals a. And then for x minus 1, right, we'll make it the opposite, so plus 1. And this has a multiplicity of 3. So let me do x plus 1, and we want to cube that one. And then we'll do x minus 2. So that's a great place to start. Now we can plug in this point, 0, negative 2. Negative 2 equals a. 0 plus 1 squared. 1 minus 2. I'm sorry, 0 minus 2 squared. Or just 0 minus 2. And let's see, negative 2 equals a. Right. And then we get, this is 1 squared, which is just 1, and negative 2 here, right? So once again, right, we have negative 2 equals negative 2a, right? So a is just 1 again, right? 1 equals a. So we can write out my equation. Sorry, my background image is moving around a bit. And we can write out my final equation, y equals 1, right? Once again, we don't really need that. X plus 1 cubed, x minus 2, right? Okay. Now let's look at this one, right? We can write out my roots. Y equals a, right? These all seem to have a multiplicity of 1, so we can say x plus 3. X plus 3, x minus 2, and then x minus 4. Okay, so we get this, but now we need to solve for our a. We can use this point, 0, negative 6. So a negative 6 equals a, right? We make this our 0, right? So 0 plus 3 is just 3. 0 minus 2 is negative 2. 0 minus 4 is negative 4, right? So let's see, 3 times negative 2 times negative 4 gives us positive 24. Now we can just divide by 24. We get negative 1/4 as our a. So let's write this out as our final equation, right? Y equals negative 1/4 x plus 3, x minus 2, x minus 4. Okay, cool. So one more of these, right? Well, let's look at this, right? So we have something like this one, right? We have our equation to start out with. Here we want to find our relative minimums and our maximums, right? So remember, these are the points, the relative maximums are where my function changes from increasing to decreasing, the tops of the hills, right? So here I see two relative maximums, one right here and one right here. We want to find those points, right? So what we can do is we can use our TI graphing calculator to do this. So let me go over to my emulator real quick. We can put this in. Let me type this equation out. So it was negative 2 x plus 2. Oh, that's not an x. So negative 2 x plus 2 x plus 1 x minus 1, and then x minus 2. Okay, and let's graph it. Let's see what we get. Okay, so this looks pretty similar to what we have on our paper, right? Now we want to find these two maximum points. So to do that, remember second trace to go to the calculate tab. Let's go to maximum. Let's go to this point first. So I'm going to go here to the top of the hill. For the left bound, remember, go to the left, hit enter. Now I'm going to go to the right, hit enter. And now it's going to find the highest point in between those two boundaries and go to the top and hit enter. And we get this point, negative 1.58. So these are my maximum, so negative 1.58. And then the y-coordinate is 4.5, right? Let's do this real quick for our other relative maximum. So here we're going to be to the left of the top of the hill, then to the right of the top of the hill, and then right at the top. Give it a nice guess. And we pretty much have the same thing. The only difference for this point is the x-coordinate is positive, but the y-coordinate is the same, right? So let's go back to our paper. Right, we know these two coordinates, right? This is 1.58, comma 4.5. Ooh, got it there we go. And this is negative 1.58, comma 4.5. All right, so here, we already know my relative minimum. I actually have one relative minimum, and it's actually my y-intercept. We could find this using the same steps in our calculator, but we already know at this point it's 0. Negative 8, let's write this out, negative 1.58, comma 4.5, positive 1.58, comma 4.5. Okay, so now we need to find our intervals, right? So this first one, right, where is our function increasing, right? Now I think there's two intervals where it's increasing. So the first one is here, right? You see this is going up, right? It's going up this way. And at our relative maximum, that's where it switches and starts going down, right? So here we're decreasing, and then at this point we're going to switch from decreasing to increasing, and once again we're going up, and then for this last section we are decreasing, right? We're decreasing. So there are two increasing intervals, right? This first one, right, where we're going to start at negative infinity. So we're going up here, right? And then once we get to this point, negative 1.58, comma 4.5, that's where we're going to stop increasing. So I'm just going to put that x-coordinate, this negative 1.58, right? Now this next interval, we know it's decreasing, and it starts at negative 1.58, and it stops decreasing at this relative minimum, 0, negative 8. So I'm going to put a 0. Now we have one other increasing interval. After 0, we start increasing again, and we go until positive 1.58. And lastly, once we get to positive 1.58, we start decreasing again all the way down to infinity, right? So from 1.58 to infinity, we will be decreasing. All right, let's look at this one. So here, this one's pretty similar, right? Let's look at our end behavior. We see this one's both pointing down, so we can give it our negative infinities, right? You see, seems like we have an even degree with a negative leading coefficient. Our degree here ends up being 4, right? Because I have 3 x-intercepts, one of them with a multiplicity of 2, right? Now the equation, let me do this real quick. Equation of the polynomial, we can take my 3 x-intercepts, right? Y equals a, and then we can go x plus 3, x plus 2, and then x minus 1. But this x minus 1 we want to square because it's got a multiplicity of 2, right? You see it hits the x-axis but doesn't cross, right? And let's plug in this point, negative 12 is 0. So negative 12, 0, so a, right? And then we can make 0. So this is just 3. This is just going to be 2, right? 0 plus 2 is 2. 0 minus 1 squared is just 1. Remember, it's still going to be positive. So 3 times 2 times 1 is 6, so we get negative 12 equals 6a, right? We divide by 6, so we get negative 2 equals a. So my final equation going to be y equals negative 2, right? X plus 3, x plus 2, and then x minus 1 squared, right? Okay, so the minimums and the maximums, let's put this equation in over here, right? So let me go back to my calculator. So we can say -2, right? And then it was x plus 3, x plus 2, x plus 2, and then x minus 1 squared. Let's graph this. Oh, what did I mess up? Let's see. So you did -2 instead of a -2, right? There we go. And let me adjust my window. So I think I need to see a little bit further in the y min direction. So let me change this to like -20. There we go. Now I can see kind of all the action going on, right? I already know I see two relative maximums, right? The one on the left over here, and then this one on the right. But this one on the right, we already know that coordinate. That's 1, 0. So really all we care about finding is this maximum, right? Let's see. So this is one going to have the coordinates go a little bit to the left, a little bit to the right, and then up top. And we get this coordinate over here, right? It's -2.56, 6.247, right? Okay, and let's find the minimum. So we can go second calc, minimum. Go left bound, right bound, and our guess right there. Okay, and we get this coordinate for our minimum. It's -0.68, -17.28. All right, so we have let's write my minimums, right? So my minimum, I just have one relative minimum, right? And it is the coordinate -0.68, -17.28. Right, and then, but I have two maximums, right? One that we had to solve for and one that we already knew. So this first one, -2.56, 6.25, and then we also have this coordinate 1, 0, right? One of my x-intercepts that I knew. Okay, so let's talk about my intervals, right? So there are 4 different intervals, right? There are 2 increasing intervals. So this first one where it's going up, we're going to start from -∞. And at our relative maximum, this -2.56, that's where we're going to switch from increasing to decreasing, right? So we're increasing there. And then at that point, -2.56, we start decreasing. And we're decreasing until we get to our relative minimum, this -0.68, right? But at this point, at -0.68, we start increasing again. And we're going there until our other relative maximum, and it has an x-coordinate of 1, right? And lastly, after 1, we will be decreasing from 1 until infinity, right? So those will be my intervals. All right. I'm going to skip this one. If you have questions about number 14, you can check the study guide. Just kind of want to get this through real quick. Okay. So x-intercepts of this here. Let's take a look, right? We've got... For this first one, it should be pretty familiar. It's basically like if we make y equal to 0, right, what's going to make this equation 0? So for this one, x could either be 2, right? We want to look at each individual part. So let's look at this one first. What makes that part 0? That's going to be 2. What makes this part 0? Here we could just take 2x plus 5 and set it equal to 0 and solve for x. So we can say 2x equals -5. So x equals -5 over 2. And then this last one, we just have x equals -3, right? So we have 3 x-intercepts, 1, 2, 3, right? So we can do the same thing. This one we're going to have to factor for, right? So let's see, our greatest common factor is x cubed. So let's take out an x cubed, right? So we're left with x squared plus 3x plus 2, right? And I think we can factor this a little bit more, right? So, right, and then we set this equal to 0, right? So we can say this is equal to x cubed. Now this ends up being x plus 2 and x plus 1, right? Because 1 times 2 is 2, but 1 plus 2 is 3. So I get my 3x-intercepts. So the first one is 0, right? We have 0. We have -2 and -1. Okay, now this one I think would be good to do with grouping. So let's group together these first two, right? So I can factor out an x squared from both of these, right? Let's factor out an x squared. And let's see, what are we left with? We are left with x minus 2, right? And then we can factor out a, let's factor out a -4 from both of these. So here we're left with x minus 2, right? And now, hey, we notice both of these terms have an x minus 2, so let's factor that out, x minus 2. And we're just left with x squared minus 4, right? Okay, this thing, x squared minus 4, we can factor even more. So we end up with x minus 2, and this is equal to x minus 2 times x plus 2, right? Our difference of squares. So here we could rewrite this as x minus 2 squared, but we see our x-intercepts are just 2 and -2, right? All right, let's look at these, right? Our difference and sum of cubes identities. So you'll have these on the test. You don't need to memorize them, but good to practice using them. So here we want to write this in the form like something cubed minus something cubed, right? This is a difference of cubes. So here, this one's just going to be x, right? So that's going to be my a, right? Is x, and our b is going to be, okay, what can I cube to equal 8, right? And that is 2, right? 2 cubed is 8. 2. So let's plug these in.
Aiden Hess, you're needed in the office, Aiden. Please
you can ignore that. So we can just do a plus b. I'm sorry, a minus b, since it's difference of cubes, right? So x minus 2. And then a squared is x squared, plus ab is plus 2x, plus b squared is plus 4, right? So that's how we could factor this one, right? Now this one a little trickier, still difference of cubes, but we want to write it as something to the third, right? So here we actually want it to be x cubed to the third. Remember, we can multiply together these exponents when we're raising an exponent to an exponent, right? And same thing here, right? So here, what cubed is 27? That's actually going to be 3. And here we can just basically take 6 and divide it by 3, and we're left with 3x squared. So 3x squared cubed is going to give us 27x to the 6. So these are my a and my b. A is x cubed, and b is 3x squared. So if I write this out, we want a minus b, so x cubed minus 3x squared. We could factor this even more, and then we're left with a squared, which is x to the 6, plus ab, which is plus 3x to the 5th when I multiply x cubed and 3x squared together. And lastly, 3x squared is going to give us plus 9x to the 4th, right? So we could factor out some of our greatest common factors here, right? So this first term has an x squared in both terms, and this one has an x to the 4th in all of my terms. So we could do that. But let's finish this up real quick. So this one is a sum of cubes. Here we've got, we could write this as, this is 6x to the 4th cubed, right? Right, because I just divided 12 by 3. And here, this is 5x squared cubed, right? So let's write this out. For our sum of cubes, right, we want a plus b, so 6x to the 4th, plus 5x squared, right? And then we'd have a squared, right, which is 36x to the 8th. And then ab, we're minus ab, so we're going to do minus 30x to the 6th, and then plus b squared, which is going to be 25x to the 4th. Okay, last one here. This one, if we just factor by grouping, let's see what happens. So this first one, I can factor out an x cubed, and now I'm left with just x plus 2. And here, what if I factor out, I think, a negative 27, minus 27, right? And we're just left with x plus 2, right? And let's see, I can factor out an x plus 2 from both, since they both have an x plus 2. And I'm left with x cubed minus 27, right? Now, can I factor this anymore? If we look here, x cubed minus 27, that's a difference of cubes. We could write this as x cubed minus 3 cubed, right? So I'll leave this one for you to do, right? How can we simplify this even further, right? This one, but over here, this is our factoring by grouping and our difference of cubes. All right, hope you enjoyed this video. Hope it was helpful. Good luck on the test.